Alright, so we'll go ahead and go over doubling time and half-life. It's kind of really similar to what we were just working on, except now we used to have like a rate where the things were changing, and now the rates are either it's double or half. Okay, so basically the doubling time is how long it takes for the population to double, and the half time is how long it takes for the population to be cut in half if you have a decreasing population, like things are dying off or something like that. So here we have the equations for each of those. We have the doubling time on top, and then we have the half time down here. Okay, so we'll go ahead and do numbers 3 and 4 right now. So for number 3, it's a doubling time problem. So we plug in the initial population, which is 23, and that's what that P represents. And then 12 is the amount of time, basically, that is in question. And then 5 is the doubling time. So that's where the 5 comes from there. Okay. Now with the next one, 160 was our initial population, and we wanted to know what happened after 500 years, and 63 is our half-life, okay, or our half-time. Alright. Okay, so those are kind of all the pieces that you need there. Now you can just go ahead and plug these things into your calculator and solve. Alright. Just don't forget to put parentheses around that fraction because that's up in the exponent, okay? Alright, so we can move on and tackle number 5 here. It's very similar to the other half-life problem we just did, except now we kind of have to figure out what the half-life is. So it says the population of the desert tortoises are decreasing by 72% each year. That's about 75%, so I just kind of rounded that up because the next part says we have to approximate the half-life. So we're just approximating, we're just kind of taking an educated guess. So if every year the population decreases by 75%, okay, and we want to know what the half-life is, and well, that's 50%, half 50. So if 50 is about 2/3 of 75%, 50 is about 2/3 of the way to 75. 25 plus 25 plus 25 is 75, and it takes 2 25s to get to 50, so that's about 2/3. So 2/3 of a year is about 8 months, right? Okay, so if there's 12 months total, 2/3 of that would be about 8. So we have to switch the years into months here. And then we go ahead and kind of plug in our initial value. Plug in the half-time or half-life here, which was 8 months. And then we plug in the amount of time that we were curious about, which was 5 years, but we got to turn that into months because our half-life is in terms of months. So we have 60 divided by 8. So when you go ahead and you plug this into your calculator, you're going to get an answer. And that answer is going to be in months. You might get like 200 or something. So remember to divide that by 12 in order to get how many years, how many years it would be, I guess. Or I'm sorry, you won't need to do that. I apologize. It just wants to know how many tortoises will be left. So the number that you get from plugging this into your calculator, that will actually just be the amount of tortoises left after 5 years. Okay. On to number 6 here. So number 6, pretty simple for the most part. For A, we want to know the initial population, and the initial population is when the time equals 0, and that's because, if you think about it, if it's the initial population, that's kind of the population before any time passed. Okay, so it's kind of the initial amount of items or people or whatever that were in that environment before time went by. So we want to know the initial population, and that's before any time went by, so we plug in t equals 0. And when you do that, negative 12 times 0 obviously goes to 0. Okay, and anything, because now this is e to the 0, 1 to the 0, 2 to the 0, anything to the 0 just equals 1, okay? So we say that this whole thing equals 1. So this is really 25 times 1, and that's why I just have 25 here. So now I evaluate and I get 26. 1 plus 25 is 26. And then I divide and I get 4,615. So my initial population before any time had went by was 4,615. Now we want to go ahead and see how long it'll be until, how much time goes by until there are 6,000 shrimp, okay, in this population. So it wants to know, 6,000 shrimp. That's the amount of shrimp we want. And so we're going to have to solve for this t here because we want to know the time that goes by. So it's going to be a lot of algebra that we do here to solve because we're trying to get t by itself. So we multiply both sides by this denominator in order to get rid of it, so they cancel out. And I just got lazy. I think I wrote same there, but we're just multiplying by the same thing over here. And then I think I get lazy again, and I just draw an arrow, but this is really that 1 plus 25 e to the negative 12t going down there because we multiplied it on this side over here. So now we divide by 6,000. And remember, these cross out because that's what we were trying to do. That's why we divided by 6,000. So what we have left is what I kind of drew that arrow for, because remember we multiplied by that over there. So we have this 1 plus 25 e to the negative 12t left. So now we want to subtract by 1. Again, we're just trying to get t by itself. That's why we're doing all of this. Okay. Because we want to find the time that went by to get us to 6,000 population. So now we divide by 25, okay? And so in this next step, we're going to have to take the natural log of both sides, and that's what you do when you have an e with an exponent in it. You take the natural log of both sides, and that will go ahead and just kind of get rid of the e and bring the exponent down, okay? So that's what I do here in this next step. I'm just rewriting that, and then we go ahead and in blue I take the natural log of both sides. Okay, so that crosses out that e there, and we get negative 0.12t equals the natural log of 19 over 20. And I wrote 20, but that really should be a 25. I apologize. It was a 25 over here. I don't know how it turned into a 20 over here. That should be 25. Okay, so now we divide by our negative 0.12 on both sides, and you can go ahead and just plug this into your calculator. This right here, you just plug in natural log of the fraction 19 over 20. Whatever you get there, you divide by negative 0.12. Okay, and we'll go ahead and get our answer at that point. Alright, if you have any more questions, just let me know.